Auzu billahi minash shaitanir rajim. Bismillahir rahmanir rahim. Today we are going to start binomial theorem. If n is a positive integer here and x and a are real numbers, then the expansion, this is x plus a, first term, second term, x is our first term and this whole power n is there, then the expansion of this is nc0 x to the power of n and a to the power of 0, okay, plus next term nc1 x to the power of n minus 1, subtract this, a to the power of 1, add 1 to a power 1 we have to take, like that nc2 x subtract n minus 2 and a square, so on nc3 x power n minus 3 a power 3, nc4 x power n minus 4 and a power 4 dot 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 dot, the last term will be ncn, okay, up to n terms ncn, x power n minus n is 0, a power n. So, this is the expansion of this binomial terms. Two terms are there, whole power n is there, then we have to write the expansion up to ncn. Okay, here we can generally denote this as sigma also. Sigma r0 to n, ncr x power n minus r and a power r. This is a general term. Each term is represented. If 0, you will get first term. If it 1, this 1, nc1 term. If you get 2, you will get nc2 part. If it is r equal to 3, then this. Like that, r2, r0 to n, we can take all these terms. So, this is a general way to represent a expansion of this x plus a whole power n is in terms of r is 0 to sigma n, ncr, this is r, ncr x to the power of n minus r, a to the power of r. Now, the coefficient of binomial expansion in the binomial expansion, that is, what is that? nc0 is a coefficient, nc1 is coefficient, nc2 is coefficient, nc3 is coefficient, nc4 dot 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 ncn. These are called binomial coefficients, and this is generally denoted as c0 to cn. Okay, instead of writing n, we can also use coefficient as c0 to n, and remember that ncr is equal to ncr minus n minus r term, if these two terms are always same, or we can write this cr equal to cn minus r. This way we can represent the coefficients, and always c0 equal to cn, and these are always 1, they are equal to 1 also. Now, the middle term in the expansion that is x power a whole power n, x plus a whole power n. In this expansion, middle terms depend on n. Okay, depend on n. First we have if n is even. Whenever n is even, we get this term Tn by 2 plus 1 is a middle term. If n value is even, this is your middle term. Second one, if n is odd, then what we have? We have two terms at middle term, that is n plus 1 by 2 and n plus 3 by 2. These are middle terms. Here middle term, you will get only one middle term. Whenever n is even, it is middle term. Whenever n is odd, ODD. So we have two terms as a middle terms. Okay, as a middle terms. Now properties of binomial coefficients. Okay, properties. What is that? First is, these are coefficients 0, 1, 2, 3, Cn up to Cn, 2 to the power of n. The sum of all coefficient is 2 to the power of n. Okay, if you take odd, second one a and b is there. So two things is there. We are taking even one, 0, 2, next 4 term plus Cn. Here n is even number, these even numbers are there, 0, 2, 4, 6, 8, 10, like that it ends. Then the sum should be these. Again, if you take odd also, C1, C3, C5, Cn minus 1, again you will get this. Okay, if n value is, this is for n value is odd, if n is odd. 0 to 4 even terms, if you take, this is there, 1, 2, 3 up to n minus 1. Here if n is odd, this is the sum. If n is even, then B part, check that. Okay, 0, 2, 4 Cn. Then this again equal to 2 to the power of n minus 1, and this nothing but C1, C3 C1, C3, C5 Cn minus 1, 2 to the power of n minus 1. Here also, if n is even. Okay. Now this is very important one. Among the binomial coefficient, the greatest binomial coefficient is, if n is even, only one term, that is only one coefficient, that is NC, n by 2 is the largest value, numerical value it has. Second one, if n is odd, we have two values, they are equal, and that is the largest in all the among coefficients, binomial coefficient. NC n plus 1 by 2 equal to NC n plus 3 by 2. These are the largest binomial coefficients of expansion if n value is odd. for even one value, for odd we will get two values. Here if n is a rational number and it is x is in between -1 to 1, -1 is less than x is less than 1, then this type of expansion 1 plus x whole power n is equal to first term simple like that, then n by factorial 1 x plus n minus 1, okay, n minus 1, then 2 factorial x square. Third term n minus 1 n minus 2 divided by 3 factorial x cube plus dot dot dot. The rth term is what? R, up to r we have to minus it, n minus dot 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 n minus r plus 1 divided by r factorial, okay, and this is x power r dot dot. That is the expansion for n is positive. If n is negative, second one, if 1 plus x minus n is there, so we have to write alternately minus. First term 1, second term will be n by factorial 1 x plus again n plus 1. Here we have to take 2 factorial x square, again minus n plus 1 n plus 2 factorial 3 x cube plus dot 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 dot. The last is minus 1 power n n plus 1. Why? Because we have to take this alternately. So r is even, then it is negative. R is odd, it is positive. Odd is odd, it is negative. R is even, it is positive. Okay. So depend upon this we have to take the value, and here n plus r minus 1 divided by factorial r, and here x power r dot dot dot, this is there. Third one, instead of minus, if it is plus minus 1, so this is nothing but first this x square, again minus x cube dot 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 minus 1 power square x square, or x power n up to n we have to write. Again fourth one, if 1 plus x whole power minus 2, in this expansion we have to write 1 2x 3x square minus alternately this 3 dot 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 minus 1 to the power of r plus 1 and x power n, like that we have to go. Okay. If these are the some special expansion of the binomial theorem you have in your exams. Now expansion, x plus y whole power 5, expand it. So we have to write that here x equal to x and x equal to x and y equal to a equal to y, that's a equal to y, and n equal to what? 5. R should be 0 1 2 3 4 up to 5 we have to take. So this is their expansion. Now we have to write this r equal to 0 to n, okay, ncr x to the power of n minus r a to the power of r. Substitute this in this expansion, you will get the value. So this our expansion, x plus y whole power 5 is nothing but 5c0 x power 5 y power 0 plus 5c 1 x power 5 minus 1 y power 1 plus 5c2 x power 5 minus 2 y power 2 plus 5c3 x power 5 minus 3 y power 3 5c4 x power 5 minus 4 y power 4 5c5 x power 0 y power 5. So this is nothing but 5c0 x power 5. Y power 0 is 1. So there is no need to write or write 1. 5c1 x power 4 y power 1, that is y, plus 5c2 x power 3 y power 2 5c3 x power 2 y power 3 5c4 x power 1 x, that is y4. Last term should be 5c5 x power, that is 1, and y power 5. Again we can simplify it. 5c0 x power 5, 5c1 x4 y, 5c2 x cube y square, 5c3 x square y cube. Next 5c4 x y power 4, 5c5 1 into that y. So this is here expansion. If you want to take this value, you can take that 5c0 is what? Factorial 5 by 0 factorial, 0 factorial, and 5 minus 0 factorial. So it is 5 factorial, and here 0 factorial into again 5 factorial. 5 factorial, 5 factorial cancel, 1 by 0 factorial is again 1 by 1, that is 1. 5c0 and 5c5, these are same. We know that. You can write. We know that 5c0 equal to 5c5. Here equal to 1. Why? Because nc0 and ncn is always 1. Using this, we can say that this value is 1. And 5c1 equal to 5c4. And this is nothing but factorial 4 by factorial 5. We can take these are these. Okay. Factorial 4 and 5 minus 4 is 1. Factorial 1. So we can write this number 5 into factorial 4. This is factorial 4 into 1. Factorial 4 cancels. So it's 5. So these two values are 5. And again 5c. 5c2 equal to 5c3. What is this? 5 factorial divided by 5c3. 5c2 equal to 5c3. So we can write this 3 factorial, 5 minus 3 factorial is how much? 2. 5 factorial by 3 factorial into this 2 factorial. So this is nothing but 5 factorial is equal to 5 into 4 into 3 factorial by 3 factorial into this is 2 factorial is 2 into 1. This and this gone. So you have 5, 4, 2, 1. This is 2, 1 is 2. 2 ones are 2 twos are. So this is 5 twos are 10. So we have all values 1, 5, 10. So substituting in this, we will get that 1 into x power 5, 5x power 4y, this is 10. 10x cube y square plus again 5c3 is 10. 10x square y cube plus 5c4 is 5. 5xy4 plus 1 y 5, or again we can simplify x power 5 plus 5x4y plus 10 10x square y square plus 10x cube y square. Again x square y cube, and this is 5x y4. The last one is y5. So this is the expansion. In this one, coefficients are 1, 5, 10, 10, 5, 1. Okay, like that we will get the coefficients. Now here we have to find third term. So first we have to write given. What is that? 2x plus 3y whole power 4. In this n is what? 4. X is what? 2x. A is what? 3y in general formula. R should be what? R is 0, 1, 2, 3, 4. Up to 4 we have to take. First, second, third. So R should be 2. In general formula, TR plus 1 equal to NCR x power n minus R y power R. This is the rth term of the series. Now we have to find third term. Okay, R should be 2 for third term, first, second, third. Okay, for third R should be 2. So T3 2 plus 1, this is third term. N is what? 4. C R is 2. X is what? 2x whole power 4 minus 2. Y is A is what? 3y whole power R, that is 2. So this is your third term. This your third term. 4c2. This is nothing but 2x power 4 minus 2 is 2. Again 3y whole power 2. So again we can simplify it. This is 4x square into 9y square. Again this is 4c2. 4 6 are 36 x square y square. This is the third term. Now you have to find this value. 4c 2 is what? Factorial 4 factorial 2 minus 4 minus 2 factorial. So this is nothing but factorial 4 by 2 factorial, again 2 factorial. So we can write that 3 2 1. Here 2 1 into 2 1. 2 1 2 1 gone. 2 1s are 2, 2 2s are. So this is nothing but 2 3s are 6. So this is 6 into 36 x square y square is the third term of this expansion. Again multiply it. 6 6 are 36, 3, 18 and 3 21. So 216 x square y square is the third term of the expansion. Like this we can find the any term. Now next question. If expansion of this term independent of x, okay, we have to find. Again we have to select that. N is what? 6. X is first term. X is this is, and A is 1 by x. Okay, these are the values. Now so take that TR plus 1 NCR x power n minus R y power R is independent. Let we are supposing that let rth term be a TR plus 1th term is a independent of x. Now we have to compare this. NC, okay, now what? N is what? 6. CR, R as it is, we don't know that, we have to find. Again this is 3x square 6 minus R. Y is 1 by x whole power R. Now coefficient, first take the common part, 6CR. Here what you have? 3 to the power of 6 minus R. Here 1 is there. So 1 in power R is R. So there is no need to take that. Now we have to separate this x. This power 6 minus R. Here 1 by x power R. If you compare this part with a coefficient of x to equal to 0 like. So we are comparing x square whole power 6 minus R. 6 minus R and this is x power minus r equal to x power 0. Why? Because independent of x term means we compare with the x power 0. Now simplify it, you will get x 2 into 6 minus r, x minus r equal to x power 0. Here x power 2 12 into 2r. Now bases are same, this is also r. Here x power 0. Again simplify it, this is nothing but 12 this equal to 3r. When bases are same, powers also, when bases are equal, equate the power. So we are equating 12 minus 3r equal to 0. 12 equal to 3r, r equal to 12 by 3, that is 4. R is 4, then substitute here, you will get the expansion. So this part you have to take. Tr plus 1, 6cr, 3 to the power of 6 minus r is the coefficient or independent term. So put it here, T4 plus 1 equal to 6c4 and 3 to the power of 6 minus 4. So this is again 6c4, 3 to the power of 2. So this 6c4 is what? Factorial 6 divided by factorial 4, and 6 minus 4 is 2 factorial. So we can write this 6 into 5 into factorial 4 divided by factorial 4 into 2 into 1. Factorial 4 factorial 2, this is 15. 15 into 9. 3 square is 9. So multiply it, 45, 4, 9, 30, 135. This is the independent, T5th is a independent term and independent of x, and its value is 135. Its value is 135. So like this we can compare with the coefficient and find the values. Again this is a very special question. If in the expansion of this, coefficient of x power 4 is, okay, if it is plus, take it plus. If in the expansion of 3x square plus 1 by 2x whole to the power of 7, coefficient of x4 is dash. Now again we have to compare the rth term, tr plus 1 equal to ncr x to the power of n minus r y to the power of r. Now compare this, okay, n is what? 7. First term x, 3x square is there, y or a equal to 1 by 2x. Now substitute here, we don't know this, we have to find this, and coefficient also 7. Cr, x is what? 3x square whole power 7 minus r, and y is 1 by 2x whole power r. Now we have to separate the constant terms. This is constant, this is also 3. 3 power 7 minus r constant. Here 1 by 2. 1 by 2 power r. This is a constant. Now x square power is what? 7 minus r. Here 1 by x we can take, and this is also r. This power should be x power 4. So we have to comparing with x power 4, this part. Now this is nothing but x power 2 into 7 minus r, x minus, if you take minus, this equal to x power 4. If this is 4, then this is a coefficient of x to the power of 4. So x is what? 14 minus 2r, minus of r equal to x power 4. So this is nothing but x power 14 minus 3r equal to x power 4. Comparing this, this is 14 minus 3r equal to 4. So 14 minus 4 equal to 3r, that is 10 equal to 3r. So r equal to 10 by 3, it is a, this is called a fraction, it is a fraction, not exactly divisible. So this expansion does not have coefficient x power 4 as a term. Therefore we can say that this is a fraction not divisible by 3. So this is not a integer, it is not integer, not a integer, it is not a integer. If it is not integer means in the expansion x power 4 does not exist, sometime if you get a integer value, then that term is this is the coefficient of that x power 4 coefficient is this. If sometime does not exist, this power does not exist, it may be 5 or 6 but not 4. In general, in a binomial expansion, sum of coefficient is 1 if power is 0. If sum of coefficient is 1, power n value is 1 in a binomial expansion, power is n, so coefficient of that is sum of coefficient is 2. This is for 0, this is for 1. If it is 2, the sum is 4. If it is a coefficient 3, you add this number, you will get 8. If you have, if power is 4, the sum of coefficient should be this. If you add this, you will get 16. A plus b whole power 5, n value is 5, then 2 to the power of 5 is 32. So 2 to the power of 5, 2 to the power of 4, 2 to the power of 3, 2 to the power of 2, 2 to the power of 1, 2 to the power of 0. These are the expansions we got from these are the coefficient, sum of coefficient is this, we got from this theorem. Okay, theorem is also there, 2 to the power of n, if values are taken as sum of coefficient. So these are the very important topic we have to complete. I have completed this now. Thank you.